Let's kick off this explainer by investigating one of the absolute coolest mysteries out there in the universe: how giant, beautifully complex galaxies violently transform their shapes over billions of years. When we look up at the night sky, we usually picture galaxies as these sweeping, majestic spirals, right? But the universe is incredibly dynamic, and honestly, it could be a pretty violent place. Galaxies definitely don't always keep their original forms. So today, we're putting on our cosmic detective hats to sift through the forensic evidence left behind at some incredibly ancient galactic crime scenes. Let's dive in.
First up, Section 1, the Galaxy Evolution Mystery and the Search for Clues.
So, picture this. When we look back at galaxy clusters from roughly 3 to 5 billion years ago, we catch this massive, dramatic shift. Vibrant spiral galaxies were suddenly being replaced by these smooth, lens-shaped or lenticular galaxies. The big question is, how exactly do they lose those gorgeous spiral arms and transform so radically? To figure this out, researchers went looking for clues. But instead of peering into the chaotic, super-dense centers of these clusters, they looked out at the quieter outskirts of a specific neighborhood called the Leo 2 galaxy group. By checking out the edges of this group, we can actually isolate the forces at play without all that overwhelming background noise you get in the cluster center. Now, for years, astronomers have been completely torn between two prime suspects. Suspect number one is the hot intragroup medium. The idea here is that as the spiral galaxy cruises through the blistering hot gas of a galaxy cluster, its own life-giving gas just gets completely stripped away, leaving behind this dead, featureless disk. Then we have suspect number two, gravitational mechanisms. This is essentially a cosmic hit and run. We're talking about galaxies literally colliding, interacting, and consuming each other, completely scrambling their internal structures through raw gravitational force.
Moving right along to Section 2, two cosmic case studies, NGC 3599 and NGC 3626.
On paper, our two victims here appear completely different, but as you'll see, they share a very dark, very violent past. NGC 3599 is a dwarf lenticular galaxy. On the flip side, we have NGC 3626, which you might also know as Caldwell 40. Now, Caldwell 40 is a giant lenticular galaxy located roughly 75 million light-years away in the Leo constellation. But despite their massive size difference, they sit at nearly identical distances from us. That places them firmly on the outskirts of the Leo 2 group, far away from that dense intragroup medium we just talked about. And what makes them absolutely perfect subjects for this study are their unique quirks. NGC 3599 recently hosted this very mysterious X-ray flash right in its center, while Caldwell 40 happens to have a really famous counter-rotating gas disk.
Which brings us to Section 3, clues in the gas.
To really figure out what happened, the researchers mapped the central regions of these galaxies using 3D panoramic spectroscopy. This gave us a truly incredible, forensic 3D look at their hidden internal movements. They were hunting for one crucial signature: decoupled gas kinematics. Okay, so in a normal spiral galaxy, the stars in the gas rotate perfectly together in the same direction, kind of like cars moving smoothly around a cosmic roundabout. But decoupled gas kinematics, that is a wild anomaly where a galaxy's gas rotates in a completely different, sometimes even opposite, direction compared to its stars. In forensic terms, this is the smoking gun. It tells us, without a shadow of a doubt, that this gas did not originate inside the galaxy. It was violently shoved in from the outside.
And when the team pointed their instruments at Caldwell 40, they found exactly that. They mapped out this immense disk of ionized gas that is spinning in the exact opposite direction of the galaxy's billions of stars. Just try to picture that visual for a second. The stars are flowing peacefully one way, and a massive river of gas is aggressively pushing right against the current. This is a colossal cosmic red flag. It points directly to an ancient head-on collision with a smaller, gas-rich neighbor.
All right, let's look at Section 4, rings of new stars. So the clues aren't just in how the gas moves. They're also hiding in what that gas is actively creating deep inside the hearts of these galaxies. On the left here, we have a highly processed color map, and on the right, emission line ratios that trace the ionized gas. When the counter-rotating gas from that devoured neighbor slams into whatever original gas the main galaxy still has left, the friction is just immense. It's unbelievable. This collision violently compresses the gas, sparking these incredibly intense periods of star formation. The data actually revealed these hidden concentric star-forming rings buried deep under heavy layers of dust. It's essentially the glowing embers of a galactic collision that are still burning brightly near the center. But hey, the smaller victim, the dwarf galaxy NGC 3599, was hiding a massive secret of its own. When researchers analyzed its emission line ratios, they didn't just find normal star formation. Instead, the chemical signatures completely matched those of a Seyfert active galactic nucleus. That means the supermassive black hole at the center of this little dwarf galaxy is actively feeding on material. And this brilliantly explains that mysterious X-ray flash researchers had detected there previously. It was actually the flare-up of an active nucleus, being powered by gas that was forcefully driven into the center by a past merger. How cool is that? So let's stack up all this forensic evidence, because a really compelling narrative is taking shape here. We've got decoupled gas kinematics absolutely proving that external material was introduced. We've got buried nuclear star-forming rings and an active galactic nucleus, showing that material was forcefully driven right into the galactic cores. Plus, we see multi-tiered, slightly oval stellar disks. Those are essentially the gravitational scars left behind when internal structures, like galactic bars, form and then dissolve in the chaos. And to top it all off, the stellar populations in these central regions are surprisingly young, less than 2 billion years old. When you put it all together, the picture of what happened here becomes incredibly clear. Which brings us to Section 5, the final verdict. It is finally time to name our culprit and lay out the exact sequence of events that reshaped these galaxies 1 to 2 billion years ago. Step 1. Minor merger. The galaxy consumes a smaller, gas-rich neighbor. Step 2. Inflow. The newly acquired gas and stars, often rotating in the completely wrong direction, spiral inward. Step 3. Heating. The gravitational chaos causes the main galaxy's stellar disk to develop bars, structurally heating up and completely erasing those neat, orderly spiral arms. And finally, step 4, compression. The infalling gas crashes into the center, getting crushed into intense star-forming rings or outright feeding a central black hole. This slow but violently transformative process perfectly explains how a vibrant spiral galaxy gets erased, leaving behind a smooth, lens-shaped disk. Based on all the forensic evidence found in NGC 3599 and Caldwell 40, the researchers laid it out plain and simple. The main mechanism of lenticular galaxy formation is gravitational, and it is not related at all to the intragroup hot medium impact. It wasn't the hot gas of the environment passively stripping these galaxies bare. No, it was gravity, cosmic cannibalism, and minor mergers that violently reshaped them from the inside out. As we wrap up this explainer, I want to leave you with this chilling, yet strangely beautiful thought to ponder. We know for a fact that our own galactic home, the Milky Way, is currently surrounded by smaller dwarf galaxies, and we are right now on a direct collision course with the giant Andromeda galaxy. So if minor and major mergers are the primary engines that destroy spiral arms and transform galaxies into featureless disks, what exactly is our own night sky going to look like a few billion years from now? The cosmic detective work never truly ends, does it? Thank you so much for joining me on this deep dive, and as always, keep looking up.